Doubt is an ongoing thing for me. It's always there. I would say I would speak up mostly in growing up. I would speak up mostly when I know what I am saying is right, or I have enough preparation. But now I'm comfortable with uncertainty. I'm like, I'm okay to be wrong, but I want this perspective to be heard. What if that brings up or open up a new discussion, and that may change the whole policy or the rules around the whole thing? So I embraced failure or not knowing everything, and I don't want to risk a new perspective not to be heard.
Welcome to Women in Quantum, the podcast that spotlights the brilliant, bold, and boundary breaking women shaping the future of quantum science, technology, and policy. Each episode, we go beyond titles and resumes to explore real journeys, real challenges, and real impact. From researchers and founders to policymakers and pioneers, these are the women driving one of the most important revolutions of our time. If you're curious about quantum, inspired by leadership, or passionate about inclusion in technology, you're in the right place. Let's get started. Today, we have the pleasure of speaking with Karuna Anna. She is a computational chemist and a machine learning scientist. Good morning, and how are you today?
Good morning. I'm doing good. I'm so excited to be here.
Thank you. So I always like to start at the very beginning. Can you tell me where you were born and raised?
Yeah, sure. I was born and raised in southern part of India, in a village called Puvanthuruthu in the state of Kerala. It is a place where people are very simple, and our life is very connected to nature.
Okay. So you back as a little girl in school in India, what were
Mhm.
you particularly interested in? What excited you?
As a little girl, I was an introvert, and still I am. And I was very curious about observing small things. For example, I was very curious about how seeds become small plants, how seeds germinate. So I used to soak seeds in water and keep on checking on them when the first root will come out. So it was a kind of a small, tiny experiment design I kept for myself. And the moment I see the root came out, it gave me a immense kind of joy and satisfaction of witnessing something concrete and tangible coming out from something invisible.
Well, that's it. I mean, that's really what probably first inspired you to study science,
Yes.
just watching the creation of life. That's just very exciting.
Yeah.
So, what subjects did you find that you really had a proclivity to?
Um, I had inclination towards arts and science together, so it was a different way of putting it. So I, in my 10th grade, I had all of those subjects, so I was happy. And in 11th and 12th, I had to decide which stream I should pick. And then I found a school which gives me literature in English, as well as I can learn biology, chemistry, physics, and everything. So it was far away. Still, I traveled to that school to get to know what exactly I want to do. And
Did you?
then
I'm sorry.
yes,
No, no, go ahead.
in my bachelor's, I was still okay. I distanced myself from literature, but I was not sure which fields of science I would like to dwell deep. So I did botany, zoology, microbiology, along with chemistry. So I had four majors. in
I
my
was like, that's
bachelor's.
a lot. Okay.
Yeah.
Did you find that you were among, was it the division between men and women when you were studying your bachelor's? Did you find it was equal?
I would say it was equal. I didn't see any distinction between more men or women, or people are favoring men more. But I feel the system is not very women inclined. For example, till I reached bachelor's, it was fine. But when women get married and then the kids come in, the system is not designed to accommodate that needs of women. That's
Okay.
where the difference came.
Okay.
But as a
Interesting.
child, I didn't feel any different.
Because that wasn't yet something you were facing in your life, and you could really understand that it seemed to be the choices that had to be made in order to pursue being, a mother with family as opposed to being maybe a professor in school
Yes.
or even like an active researcher, scientist. Interesting. Were there any teachers or mentors in India who had a big impact on the direction that you took when going into computational chemistry?
Yes, I would say that is my PhD supervisor. She is Dr. Durba Roy, and she made it very particular to give more importance to women in research. When I joined the lab, it was women only lab because she didn't have a good time when she was doing research. She was the only woman in that lab, and she had to what always prove that she belonged there. That made her make sure that the next generation should not face that. So it's her personal choice and her effort that gave me that inclusivity and a space where I don't have to always prove myself that I belong. I could concentrate, or I could put that energy on something else.
Okay. So at what point did you realize that computational methods would be the central part of your career?
That was when, I mean, I during my masters I did experimental chemistry, and this computational chemistry I was told that it is mostly math heavy, and mostly men are more successful there, and women will go to mostly biology kind of things, or maybe humanities side. And to be honest, I didn't have very good math background. I did mathematics only up to the 10th grade. But this supervisor gave me a chance because saw that I had this curiosity to know. And she gave me the opportunity to learn math as I go in. Like when I need to learn some concept, go back and learn it. And that gave me the whole new perspective. And after I was done with PhD, there was no going back. I was like, this is where I belong. I want to contribute more to computational chemistry and to reveal how chemistry or quantum chemistry really uh, give meaning to, or bring out the mechanism of things that is happening and how to explain things in a very fundamental way.
What early challenges did you face in your education or your research, and how did you overcome those challenges?
Oh, challenges is the I did not have challenges as in this gender bias kind of
Right.
things, but I had technical challenges such as
Okay.
uh, uh, when, for example, this math background is not something I had, and I was the first student in my PhD group, so we had to set everything from scratch. So that was, I would say that that was an opportunity to be a part of building something new and witness the whole struggles of bringing things together, talk to people, talk for quotation, and bring money and divide that money based on like how long do we have funding and what is the direction we have to go forward. Those were, I would say that those were challenges and opportunities together. And then I moved to USA for postdoctoral research. There I had to unlearn many things which I learned back in India. The way, it's not like there is a right way of doing things. Different cultures have different way of doing things. So to interact or to collaborate with people from who are born and brought up in a different culture, I need to know their culture a bit. I need to at least keep my culture a little bit to myself, and don't expect everyone to know how I am brought up, and give everyone some grace to know each other, not just for the science, but for the human level of things. That that is a different perspective which I learned.
What motivated your transition from academic learning in India to working internationally as a scientist?
Could you please repeat that question?
What motivated your transition from academic learning in India to working internationally as a scientist?
Oh, I wanted to try out. I wanted to see how things work internationally, and it's all new experiences. Whenever I was born and brought up in southern part of India, and India has a different, it is rich in different cultures and languages. So if I cross from one state to another, I need to learn a new language. And I went to five different states and learned. So that gave me a sense of, I love to travel, I love to explore new culture. Just that I didn't need passport to do that. And to come to US, I needed visa and passport. So that was the only difference when I had to move. So I was like, why not? Just go and try and learn things, how people work there, how are there possibility to go further than what India can provide. That was the motivation.
So then when you came to the United States, that was for your first professional role after graduating?
No, I worked for a startup company back in India for some months, and I understood that industry has a different way of doing things than academia. And that did not suit me in that stage of life because I had a small baby at that time. So I thought, okay, I'll take a break and then I'll try new avenues. That's when I applied to US and then came here.
So what skills or experiences from your time in India continue to benefit you in the work that you do now?
In India, I am from basic science, but I have multiple majors. And now it is a multidisciplinary world. Let it be research, let it be academics, let it be anything. So that helped me. So if it is a biology related research, I have that background. If it is a chemistry research, I have the background. If it is computational chemistry or machine learning, I had that background. So that's a interesting combination of skill set. I mean, that gives me some kind of confidence to take up new roles in research. And here I am the first person to be recruited in this lab too. So I am mentoring all the PhD students and master students here, and I open new avenues in research here. So that academic upbringing or the educational background back in India, there it is more strict and disciplined. So if I want to learn a new thing, I really have to take a degree in that. And I got the opportunity to take the four majors, and that helps me even now.
Okay. How would you describe your role as a computational chemist to someone outside of science?
Yeah, this is a thing I always uh, try to explain. Like, with a story, for example. So it is like I am communicating chemistry, which is with beakers and pipettes, to a machine, to a computer, to tell it to do. I'm telling the computer to do that experiment for me. So computer doesn't understand what is water, what is salt, what is sugar. So everything it learns in zeros and ones. So what is the combination of zeros and ones I should put for the computer to know what is water? That that research is already done. I don't have to reinvent the wheel. I just have to make different combinations of it to represent a real world molecule and how it evolves. If I give the equation, physics equations, and the chemistry molecules in zeros and ones, the computer is able to do that far faster than me because I need to take a nap, I need to do many other things in my real world. But the computer, if I set it up, it is able to run it for me, and I can always retract it. What are the path it went through to reach that product? And that gives me the mechanism, how it reached there, and what I need from there, and what is the whole structure of it in an atomic level or in the whole bulk level. So this is the interesting new world that the computational chemistry opens to everyone who wants to know the mechanism behind anything that works.
What excites you the most about using computational tools to study chemical systems?
I can always play with it without paying again and again for the chemical. And it's like I might I have to build the tool and I can use the tool again and again. I don't have to pay and wait for the vendor to deliver me the chemical and the solvent, and I don't have to wait for it to react in real time. And this computational chemistry helps me predict what is the output of a reaction is. And I am not wasting a lot of resources to come into a hypothesis or conclusion. I can run millions of experiments in computer and shortlist them to top 5 or 10 for the experimentalists to check. If we had to do all of this experimentally, it takes more than my lifetime to come up with a theory.
So, your work often combines simulation and machine learning.
Yes.
How do you integrate those approaches in your research?
Machine learning, I would say it is a new term for pattern learning or statistics. So now it is more relevant because we have access to a lot of data from all across the world. So that is the very systematic or intelligent way to do things right now because we have an information explosion right now. What I do right now is do machine learning first. Learn from pattern, not from mechanisms. And then if I see an interesting pattern coming up, which is relevant to my research, I take them and learn the mechanisms through simulations. So machine learning takes very less amount of time to come to a narrow down or shortlisted set of things. And from there, I do mechanistical model, which is simulations, which will give me an insight to really whether I really want to pursue it or not experimentally. And from there, I shortlist it to one or two for the experimentalists to work on. So it is mostly a top down approach where we have a lot of things happening in the beginning, and most of them may not be really relevant to the question I'm asking. All of those compounds and all of those results are relevant, but not exactly to the question I'm asking.
Is there a recent project that you can talk about that you're especially proud of?
Yes, I would say a couple of them. And first one I would say is like getting, I am designing some molecular filter, or I can say that molecular pickers, which can selectively pick those metal ions which are very important in national security or building electronics, for example. Those are, we call them critical minerals, because that is very critical in any country's security and progress towards energy related research. Nowadays, with this machine learning and quantum chemistry, every country is trying to bring their stand in quantum chemistry. For all of those, we need very efficient electronic devices. For example, right from phone to laptops to many supercomputing devices. All of them need specific metal ions, and they are not widely found. For us to mine them from underground, it takes a lot of time. A lot, we are polluting the environment. Many things are happening, but on a day-to-day basis, we are discarding a lot of electronic waste, and that goes to dumps. What I am proposing or what I am working on is like recycling those metals from the electronic waste. And recycling takes a lot of time because they all are heated together, merged together, molten form they are. And to separate them takes a lot of time and effort. What I am designing is a very specific selective molecular glue kind of molecule, which can really go and attack these specific metals alone and concentrate. And we are very successful in finding those molecular filters.
It's interesting. How do you stay up to date with new computing tools, algorithms, and scientific literature?
I would say that it all depends on what, because every day in minimum hundreds and thousands of tools are coming up. So it's impossible to know all of them. But if in my field, what is required, I will learn them and I will build off from them. That is the way I work, because there is always something which somebody has always created. And I don't have to reinvent the wheel. I just use that wheel, different layer on that for my specific purpose. So my work in this lab is mostly tool building for specific application. The tool remains the same. The applications keep on building.
Okay. How has your international experience shaped your perspective on science and collaboration?
I would say that science is a fluid medium, and our culture, different cultures have, uh, the culture of different people will give a different perspective or lens towards the research problem. And I would say diversity is a very, very strong tool which we need to tap in to get the science moving. Because I would say that in India, how I did research is completely different from what I see here. And I am nurtured and I have a totally different perspective right now merging these two.
Hmm.
And this is something people really don't think much into we when we say science, it's always hard skills, not the soft skills. It's about technique, how much technique you know. But no, it always goes hand in hand. The human resources and the cultural background, the language, because the people who knows different languages, multiple languages, they think in a different way than the people who has one language, mother tongue, or the home language is the same as the language in which you are studying, you are doing research. If all of those are the same language, they have a different set of skill set, which they are very refined in compared to the people who talk different languages. I have seen it in firsthand.
When you're facing doubt internally, what's your process for deciding whether to speak up or to step back?
Self doubt is an ongoing thing for me. It's always there. I would say I would speak up mostly in growing up. I would speak up mostly when I know what I am saying is right, or I have enough preparation. But now I am comfortable with uncertainty. I'm like, I'm okay to be wrong, but I want this perspective to be heard. What if that brings up or open up a new discussion? And that may change the whole policy or the rules around the whole thing. So I embraced failure or not knowing everything, and I don't want to risk a new perspective not to be heard. It is a process, ongoing process, to understand that it is okay to fail. It is okay to say, "Oh yeah, that's a new perspective," but this is the drawback of it. Yeah, I now I get it. Now I understand. I am growing. I am learning to do that.
What do you see as the most promising near-term application of quantum computing?
I am not. I don't have much background on saying quantum computing as such, but I can speak for quantum chemistry that they are related, and I would say the quantum chemistry and machine learning. Actually, quantum chemistry is very in depth, and it took a lot of compute. So even if quantum chemistry was the main discoveries in quantum chemistry happened decades ago, people were not exploring it much because it was computationally very expensive, and we couldn't afford to wait so long to get one reaction and say that okay, that doesn't move forward. That was the bottleneck. Now with this explosion in machine learning and pattern learning and all this computing system coming up, this is the most interesting time in my research, I would say, because we can club both these together. Quantum chemistry gives the maximum in-depth knowledge, and machine learning gives the maximum advantage of doing things faster. This gives a lot, the courage to ask difficult questions.
That's true. And it's so important to ask questions and not just smile and nod and pretend like you know what's going on. It's more important, to ask the questions and find out. What advice would you give young researchers in India who want to work internationally?
I would say knock every door. Don't be don't wait for somebody to direct you. Just knock every door. Take every internship you can and explore. You should not do internship just in your own field. Open to new turns in your life. That is the way you will find what exactly excites you. And you never know, the door is next to you. Maybe that's far from you. So, but keep knocking the door. and embrace every opportunity you get.
What supports or changes do you think would help more women pursue careers in computational chemistry?
I would say the starting, there is no barrier, at least from my experience. But to stay in that career, computational chemistry is a daily evolving field. So to stay in that career, you need to be working every day. And from a woman's perspective, we need to go for maternity leave. We need to take care of the children and we need to write grants. So it is not really designed for us. We should always speak for us. We should ask, okay, this is where I need more time or I need more accommodation for. Because having a child is not just the women's responsibility, it is for the whole humanity to go to the next generation, next stage. So that should be taken as the society's responsibility. If the women should not be penalized for taking that break. And men also should get that break from their work if they are planning for having a child. That's what I would say. Because I have seen people, women coming into computational chemistry and get stagnant there because they had to take a leave. And then they couldn't cope up because within that gap of, say, 2 or 3 months, things have changed. And then they take a different role and not stay in computational chemistry. That's very sad.
What advice would you give girls and young women considering a career in STEM?
I didn't get that question.
Oh, what advice would you give to girls and young women who are considering a career in STEM?
I would say that don't label you as a woman. Just it's the same for men and women to start career because our gender doesn't discriminate. We should not let our gender discriminate against us. If somebody is doing that, it is their problem. It is not my problem. And approach science the way it should be. Okay, there are certain subjects we find it tough to do,
Mhm.
and that is true for men too. And okay, if this is tough for me, I'll go again, try, I'll practice and get back. I should not say that okay, I this is tough for me. I think for girls find it tough. Also, maybe I should derail from here and go try something else. No, if you are interested in that, keep on trying and you'll get it. There
I
is nothing, nobody came here learning everything. We all started the same. We all started crying for food. And we all
true.
started walking. While walking, we all stumbled and fell. It's not like boy kids fell less and girls fell more. No, we all learned the same way.
It's true.
It's the mental block, I would say.
Yeah, I think you're right. What trends in computational chemistry and machine learning are you the most excited about right now?
I would say I'm more excited and scared because there are a lot of things coming up. And before even trying to understand what it is outdated and irrelevant, and something else is coming up. So it's a more exciting and challenging, and keeping pace with all of those is really tough. So I would say focus on what you want to solve and take which computational chemistry piece will fit your goal. Don't try to take it as a method. Take it as a path to solve your question or to get answers to the questions.
What is one misconception you hear about computational chemistry that you wish people understood better?
People think that computational chemistry is a black box. It's like, okay, if I tell whether this or that will work together, I can just put that into the black box and it just gives the answer. No. For computational chemistry, we should know computer, chemistry, physics, and everything around it. So there is a lot of domain knowledge that goes behind the scene to get a reasonable results from computational chemistry. So it is not just running a software. It is every time checking whether what we are getting is right. And there is no software that can do everything. We build our own tools. We write codes based on chemistry and the laws of physics using computer language. So it's an amalgamation of many things coming together under one umbrella.
How do you balance long-term research goals with the need to produce results on shorter project timelines?
I would say that it is long-term research is like a journey, and shorter getting to results is like giving report of what is done so far, like in maybe in a couple of months or maybe in 6 months or in an year. So I would say that the first year or when we start out a new project, it is mostly about learning, unlearning, failing, and we need to give ourselves some grace and talk in advance, saying that, okay, to whoever we need to show results to, saying that this is the new thing and these are the probable roadblocks I will have. And based on that, I would say that talking in advance or giving the report in advance, saying that these are the roadblocks I would have, and that would need some extra time to clear and to get to results. And that should be reflected in our planning as well. So we should not overcommit on results in the initial time. It's always commit less and do more. That's my strategy whenever there is an ambitious project. If it is a similar sideline projects, we can have uh, results back to back. But if it is a long-term focused one, it's tough.
Beyond,
And my strategy is to tell in advance that this is going to be tough for the first 6 months or 1 year. And in 6 months, I found that this is not going anywhere. So I will not wait till 1 year to make them know that this is where things are and we are taking a different direction from here.
beyond technology, what personal values drive your work in science and community building?
I would say that make room for everyone who wants to try. And we all are, at the end of the day, humans. And we all have our own timelines and our own goals and ideas. It's mostly about emotionally intelligent leader. If we are given a leadership opportunity or a decision making power. So give space to everyone and make them as comfortable as they are. And if we are in our authentic self, we perform better. That's true for everyone who is coming into the room for the first time or who are there for longer time.
I think that's the message I want to leave this on. I love what you had to say. And if people want to find out more about what you're doing, how do they, where should we send them to?
They can reach out to me in LinkedIn or I can leave my email with you.
Oh, it's fantastic. I'll definitely include your LinkedIn profile, and I thank you so much for your time today. I know we had a couple scheduling bumps, but I really appreciate
Yeah.
having you on today. And thank you so
Thank you.
much for your insight. I really appreciated it.
Thank you so much.